In this example, we're asked to graph the function f of x equals 2 minus the square root of x plus 1. So we're going to go through our usual transformation rules I usually use here, and that's just inside affects the x values in the opposite way. So inside I see an x plus 1, okay, which means the transformation rule I'm going to use there is just x minus 1. I'll subtract 1 from x values. And then our other rule is the outside affects the y values in the same way. Now, on the outside, it gets a little confusing with the order that it's written. A lot of people get mixed up with this, but it's not about the order, it's how it's connected to the radical. Right now, this 2 is connected by addition and subtraction to the radical. The 2 is a positive 2, so we will be adding 2 to the y values. I also see this minus sign though. So what does that do? Well, that's in front of the radicals, so it's connected to the radical, and essentially meaning that we have a negative 1 sitting in front of the radical, connected by multiplication. So our other thing that's happening is we have to multiply y values by negative 1. Remember that you can always rewrite this equation if you are having a hard time looking at it like this. This is the same thing as f of x equals negative square roots of x plus 1 plus 2. In the same way that you hopefully know 2 minus x is negative x plus 2. Those two things are the same thing. It's the same situation here, just with a radical, so it makes it a little bit more complicated looking. But now that we have our transformation rules, we're going to go ahead and use some points from the basic function. The basic parent function is the square root of x, and we usually use the x values of negative 1, 0, and 1 for the points we use as reference points, since most of the parent functions are centered around 0. Now, if we try to take the square root of negative 1, it doesn't actually exist, so we can't actually use that point. Square root of 0 is 0, square root of 1 is 1, and then it really helps to have a third point just to help us get the shape a little bit better. So I'm going to use the next one, that number that I can actually square root and get a whole number, and that's 4. The square root of 4 is 2, so that will be the other order pair I use. And these are the points I'm going to use as reference just to help me graph this. Now, as I do most of the time, I will start off by doing all the x rules, and then I'll go back and change all the y values, so we don't have to bounce back and forth between the two rules. So my x rules here are x minus 1, so I'm taking my x values and subtracting 1. 0 minus 1 is negative 1. 1 minus 1 is 0, and 4 minus 1 is 3. I'm going to go ahead and change and do my y rule now that I've finished off my x's. So my y rule consists of two things. It consists of multiplying by negative 1 and then adding 2. So 0 times negative 1 is 0, plus 1 is 2. 1 times negative 1 is negative 1, plus 2 is 1. And 2 times negative 1 is negative 2, plus 2 is 0. So there we have our three transformed points. This is for the function f of x. Now we just need a coordinate plane so we can graph it. And I don't actually have a coordinate plane to import, so I'm going to roughly graph this as best as I can here. I'll just give myself 4 tick marks on each axis. I'll plot my points. So my points here are negative 1, 2, which is right about there, 0, 1, there, and 3, 0. Now, if you know what a square root function looks like, the parent function typically starts at 0, 0, and then curves off to the side. So in our case, we're going to start at negative 1, 2, and then we're going to curve off the side through the other 2 points. So it will look hopefully something like that. And I kind of missed the points there. Sometimes it is a little bit hard to draw it accurately. But hopefully you get the point I was trying to make by drawing that in. And that's it.